Okay, so yesterday or the past couple of days, we've been talking about combining like terms, and we found out what like terms are. And today we're throwing in another aspect to that, which is the distributive property. So you will have a notebook entry today, and it is called distributive property. Now, what does distributive property mean? Well, it means, I'm about to give you some alphabet soup, so don't freak out on me, okay? It means that if you have a group B plus C times A, that is the same thing as A times B plus A times C. I know that means absolutely nothing to you right now. But what this is saying is that if you add what's in the parentheses first, then multiply that sum by the outside number, you will get the same answer if you multiply the outside number times each inside number then add them together. So, if you add what's inside B plus C, and then you multiply whatever B plus C is equal to times the outside number, you'll get the same thing as if you said A times B first plus A times C. Now, I know that still seems like it's clear as mud, but let's put some numbers in, and I think it'll make much more sense. So, let me change colors. If you have eight times 3 plus 4, you could say, because remember PEMDAS, please excuse my dear Aunt Sally, or parentheses first, exponent second, multiply or divide, then add or subtract whatever comes first. Remember that? Well, if you went by that, then you would need to work what's in the parentheses first. So you would say 3 plus 4 is 7. And then if you multiply that times 8, you're going to get 56. Well, let's try to distribute. So up here we said A times B plus C was the same thing as AB plus AC. So if this is A and this is your B plus C in numbers, then we could also do this. 8 times 3 plus 8 times 4. Let's see if we get the same answer. 8 times 3 is 24. Bring down your plus sign. And 8 times 4 is 32. then if you add those together, you get 56. So this is equivalent. You could do 3 plus 4 first and get 7 and then multiply 7 times 8, which is what we did, and we got 56. Or you could distribute and say 8 times 3 plus 8 times 4, which is what we did here, and we got the exact same answer. So why would I want to use distributive property if I can just add these two together and get the right answer when I multiply it times 8? Well, the reason you would want to use the distributive property is because you're not always going to have numbers that you know. You may have variables. For instance, you could have, I'm going to change papers. What if you had 5 times x plus 5? In this case, I don't know what x is. So therefore, I don't know. I can't add x plus 5 because I don't know what x is, for one. But I can simplify this, which is what we've been doing. We have simplified. I could say 5 times x, and I would get 5x. Bring down my plus sign. 5 times 5 is 25. So I have simplified this to 5x plus 25, and we know that this is an expression because we don't have an equal sign. Now, what if it gets longer and longer? What if this said 2 times x plus 5 plus 2? Could we simplify this? Sure we can. We could figure out what 5 plus 2 is, but we don't know what this x is. So we have to simplify by using the distributive property. So we would say 2 times x, which we could write like this. Bring down your plus sign. 2 times 5. Bring down your plus sign. And then 2 times 2. Now we can simplify from here. 2 times x is 2x. 2 times 5 is 10. Bring down your plus sign. And 2 times 2 is 4. Now we can simplify from here because this just looks like an expression that we've been using, right? So I don't see that there's anything I could combine with 2x. There are no more x's. So I would just bring that down and it would be 2x. But I do see that I have positive 10 and positive 4. Positive 10 plus positive 4 is positive 14. So I have simplified this 2 times the group of x plus 5 plus 2. I simplified that to 2x plus 10 plus 4, and then I simplified it even further to 2x plus 14. And when we get to equations, yes, it takes up a lot of space, but it helps you. This looks much easier to solve if we had an equal sign and another number than if it were this, right? So simplifying using the distributive property is very important. Now I want to show you a way that I think helps people remember the distributive property. So I'm going to write distributive property across the top again. And I tried to use bigger markers this time so you could see it a little better. So let's say we have 6 times the group, and the group is always in the parentheses, 2x plus 5 minus 6x plus 2. So this says 6 times the group, 2x plus 5 minus 6x plus 2. We don't know what x stands for, so therefore we can't just combine these. But we just finished trick-or-treating, right? So if we finish trick-or-treating, did you just go to this first house and you said, okay, I've got enough candy, I'm going home? If we visualize these numbers as houses, because it's very important that you multiply the outside number times every number inside the parentheses every single time. If we visualize these as houses, this is a house, this is a house, this is a house, and this is a house. And you're going to go trick-or-treating. Let's dress this number 6 up like a pumpkin. Give it a carbuncle. And give it some twirly whirlies. You're a cute pumpkin for Halloween. Trick or treat. You're not just going to trick or treat this first house. You want to go to every house in the neighborhood, so that way you get lots of candy and not just one house. What if they didn't even have good candy? What if they're handing out black licorice or something that you really don't? Black licorice is my least favorite. So what if they're handing out black licorice and they're giving out Snickers bars and they're giving out Laffy Taffy and they're giving out sweet tart ropes? I want to go to all the houses. So I'm going to trick or treat each house. So the way I like to have my children remember the distributive property is trick or treat all the houses. And that's just my little quirky way to help you remember it. We're going to trick or treat all the houses. So let's rewrite that again. And I'm just going to write the same thing and leave all the costumes and houses off so we can look at it again. So we're going to trick or treat all the houses. So we said 6 times the group 2x plus 5 minus 6x plus 2. 6 times this group. So when we trick or treat all the houses, we're going to say 6 times 2x. 6 times 2x. Bring down the plus sign. Then we're going to say 6 times 5. Bring down the minus sign. Then we're going to say 6 times 6x. Bring down the plus sign. And 6 times 2. And really, I don't usually write this out, but I'm trying to help you visualize exactly what I'm doing so you know what's going on. So I just said 6 times 2x, and that would give me 12x. Don't forget your variable. Bring down the plus sign. 6 times 5 is 30. Bring down the minus sign. 6 times 6x is 36x. Bring down the plus sign, and 6 times 2 is 12. Now, that looks a lot less scary than this looks, but we can make this even less scary. So, I'm going to see, do I have any more x's? I do. I have positive 12x and I have negative 36x. So I can add those together. So I would have, I'm just helping you visualize this, positive 12x plus negative 36x. My signs are different. That means I'm going to subtract, and I would get 24x, and it's negative. So I can go ahead and put that up here. Negative 24x. Okay, now I see that I also have these numbers that are like positive 30 and positive 12. So if I have positive 30 plus positive 12, my signs are the same, so that means I'm going to add, and I'm going to get positive 42. So I just put that up here. So now I have simplified this all the way down. I went from 6 times the group 2x plus 5 minus 6x plus 2, and then I got this 12x plus 30 minus 36x plus 12, which looks just like the expressions we've been working on for the past couple of days. And then I simplified it on down to negative 24x plus 42. And that is as simplified as I can go. So that would be my answer if I were asked if I could simplify this expression. Okay, so again, I like for you to remember it as trick or treat all the houses. You don't just trick or treat the first house. You want to go to every house in the neighborhood. Okay, let's try another one. This time, let's add another variable. What if we had 5x times 5 minus 2x plus 3y? What would that look like if we distributed 5x? Because we don't know what x is, but we can distribute that. So let's trick or treat all the houses. So we would get 5x times 5. So that would look like this. 5x times 5. Bring down your minus sign. 5 times 2x. Bring down your plus sign. 5 times 3. Oh, I'm sorry. 5x times 2x. And 5x times 3y. I'm sorry, I wasn't paying attention. See, it's easy to forget that x. Don't forget it. Now, what would this become? Well, 5x times 5 would become 25x. Bring down your minus sign. 5x times 2x would become 10x squared. Why did that become x squared? Because I had an x times an x. So that is x squared. Plus 5x times 3y. This would become 15xy. You've got to bring those variables. So this looks a little different. Now I can simplify. Again, I have to have exactly the same variable to simplify. And now it says 25x minus 10x squared plus 15xy. I don't have any that are alike. So you're right. This is as simplified as I can get this expression. I'm going to give you one, and I want you to pause the video and try to simplify it yourself. And then you will have some work to do. And then tomorrow you will be working on Khan Academy to simplify expressions. I will assign it through Khan Academy. So make sure you are logging in tomorrow and doing that work. Okay, this one's for you to try. I want you to do 3 times 7x plus 4 minus 3x. Go ahead and distribute that. Remember, trick or treat all the houses. Pause the video and try to use the distributive property. Okay, so if I were going to trick or treat all the houses, I would say 3 times 7x. So 3 times 7x. Bring down the plus sign. 3 times 4. Bring down the minus sign. And 3 times 3x. Now, I can simplify this even more. So 3 times 7x is 21x. Bring down the plus sign. 3 times 4 is 12. Bring down the minus sign. And 3 times 3x is 9x. Now, can I simplify this even more? Sure I can. I see that I have 2 with the variable x. So 21x and negative 9x. I can combine those. My signs are different because this is a positive 21 and a negative 9. So if I were going to subtract 21 minus 9, I would get what? Just 12? No, 12x. And my largest absolute value is positive, so it would be positive 12x. And then I would just bring down my positive 12. 12x plus 12 is as simplified as you can go. So I hope you got 12x plus 12. Okay, let's try another one. This time, let's try 9 times 4 plus 3y minus 6 minus 2y. Pause the video and use the distributive property to find the answer. So I would trick or treat all the houses. I would say 9 times 4. Bring down your plus sign. 9 times 3y. Bring down your minus sign. 9 times 6. Bring down your minus sign. And 9 times 2y. Okay, now we can simplify this even further. We could say 9 times 4 is 36. Bring down your plus sign. 9 times 3y is 27y. Bring down your minus sign. 9 times 6 is 54. Bring down your minus sign. And 9 times 2y is 18y. Now, I can look for like terms. So I have positive 36 and negative 54. So I'm going to come down here. If I have positive 36 plus negative 54, the signs are different, which means I'm going to subtract. So 54 minus 36 gives me 18. So, and I keep the sign of the largest absolute value, which is negative 18. And now I see that I have also two like terms. I have positive 27y and negative 18y. So positive 27y plus negative 18y. My signs are different, which means I'm going to subtract 27 minus 18. And I'm going to get 9. And don't forget the y. Don't forget your largest absolute value is positive. So it would be negative 18 plus 9y. And that is as simplified as we can get on this expression. Okay, I'm going to give you a few to practice on your worksheet. Make sure you submit it so I can see what you're doing, and then we'll practice some more tomorrow. And we'll be on the distributed property for a while. So if you're not getting it the first day, that's okay. We're going to practice a whole lot more because distributed property takes us a little while to really get it down good. So good luck and have a great day. Bye-bye.